Okay, for what we have in problem number 3, we're going to have a ratio that is going to be a cube in the numerator and a quadratic expression in the denominator. Okay, and since the degree of the numerator is greater than what we have in the denominator, we're going to be looking at long division. And so as we take the divisor, in this case the denominator x squared minus 2x minus 24, into the numerator, or the dividend, 2x cubed minus 4x squared minus 47x plus 9. Okay, for x squared into 2x to the third, okay, we have 2x, and then multiplying the divisor by 2x, we have 2x cubed minus 4x squared minus 48x. And as we subtract, okay, the product from the dividend, okay, we end up with x plus 9, and this will be the remainder. And so for what we have in the development, okay, now we have from the original ratio, 2x cubed minus 4x squared minus 47x plus 9 over x squared minus 2x minus 24 dx. Again, this is going to be 2x, and then we have plus x plus 9 over the denominator. Okay, x squared minus 2x minus 24, and we're going to go ahead and just write this out in factored form. Okay, so we have x minus 6 and x plus 4 factored from, again, the quadratic trinomial. And now for part of the solution, okay, we can go ahead and arrive to the antiderivative of 2x, which is simply going to go to x squared. And then the other antiderivative, okay, this is where we're going to officially work on the partial fraction decomposition. And so for what we have in the group of terms, okay, for x plus 9 all over x minus 6 times x plus 4, okay, what we're going to have to develop in this particular case is that for x plus 9 all over x minus 6 times x plus 4, okay, we can write breaking up into two distinct fractions with the denominators of x minus 6 and x plus 4, and it doesn't matter again what order the denominators would come in, but we'll let a be place over x minus 6 and b over x plus 4. And as we clear away the fractions, okay, we have x plus 9, where a will be distributed over x plus 4 and b over x minus 6. And in looking at our distinct zeros from x plus 4, we can set x to negative 4, and for x minus 6 we can set x to 6. And going ahead and solving for a, if we set x equal to 6, okay, we have 6 plus 9 is 15, 6 plus 4 is 10, 6 minus 6 is 0, so we have that 15 is equal to 10a, and a is going to be 15 tenths, which we can reduce to 3 halves. And as for the other 0, okay, we can set x to negative 4, and so if we do this, okay, we have negative 4 plus 9 is 5, negative 4 plus 4 is 0, negative 4 minus 6 is negative 10, and which will be multiplied by b, and so b is going to be at negative 5 tenths, and we can write as b is equal to negative 1/2. So for the partial fraction decomposition, again, we have 3 halves over x minus 6 as well as negative 1/2 over x plus 4, and we can re-express this partial fraction decomposition as 3 halves times the quantity of 1 minus x minus 1/2 times the quantity of x plus 4. Okay, and now having established the partial fraction decomposition, okay, we can carry over this particular set of terms and integrate. And so for what we are going to have, okay, throughout in the process is that for, once again, we have from 2x, we have the antiderivative is going to be x squared, and then as we look at integrating, once again, after having taken the partial fraction decomposition, this ratio, okay, we can further expand where we have x squared plus 3 halves times the integral of the reciprocal of x minus 6 dx minus 1/2 of the integral of the reciprocal of x plus 4 dx. And from this, okay, nice thing is that both x minus 6 and x plus 4, okay, have derivatives of 1, and so we just have again another set of fairly basic natural logarithmic terms. And so for the final solution, okay, this can be displayed in the form whereupon we have from the original quotient, okay, from from 2x, we have again the antiderivative is x squared, and then from the ratio resulting from the remainder, after taking the partial fraction decomposition and integrating, we have also the second antiderivative, which we have at 3/2 the natural logarithm of x minus 6. And then for the last of the three antiderivatives, we have negative 1/2 of the natural logarithm of x plus 4, and then we have followed by the constant. So in the final result, we have three antiderivative terms followed by the constant.